Okay, it's 7:30. So yeah, so please take your seats and we will start the lecture shortly. Okay. And you can always use, nowadays a lot of social media tools, WeChat, WhatsApp, Signal to form your groups. Okay. So yeah, I'm not too worried about that and hope. But still, if you cannot get into a group within this week, okay, just let me know. Okay, send me an email. Okay, so without further ado, let's start today's lecture. I'm Dr. Richard Lee. I'm been working in the VR, AR, and also game industry for over 15 years. So yeah, so this subject is called extended reality. So which means that you will see a lot of different realities. So for example, virtual reality, augmented reality, mixed reality. Okay, so we will talk about some of them in very detail, some of them in very brief, because virtual reality has already been around for over 50 years. Also, okay, later on we will see the history of virtual reality. But for other realities, so for example, augmented reality, it has been just around for very briefly, and also there are too many details. So for example, whether the augmented reality is mobile-based augmented reality, or is the AR that is done through the optical illusion. So for example, the HoloLens, Microsoft HoloLens, which is we call it the see-through, optical see-through AR glasses. Okay, so there are just too many of these little details, and I will try to, cover as many as possible within this course, but do not expect I talk a lot, or cover everything that has been around, okay, for a while. So yeah, so let's have a look at some of the basic information. By the way, this subject will be video recorded, okay? So if you have some concerns regarding you being, recorded into the video, you can just sit at the back, or go to the next room, okay? The 604B. But if you want to see me, come to this room, okay? 604A. So I think we have some prerequisites. So for example, basic knowledge in Unity programming is preferred. Okay, so if you are very experienced in Unity programming, I believe that you will benefit a lot, okay, from your previous experience. The next was the tutorial videos. If you are not familiar with Unity, okay, so I have already uploaded quite a lot of videos into the into Blackboard. So I know this is the first semester you are here, okay, for this Metaverse Technology Master Program. So Blackboard or Learn at PolyU is the main portal for our communication. Okay, so if I have any announcement, I will announce through Blackboard. Okay, you get your learning materials from Blackboard. You also submit your assignments through Blackboard. Okay, and also, if you have any questions, you will always find my email on on the first page of the slides. Okay, so you can send me an email. Next tutorial time, of course, 6:30 to 7:20. Okay, so today there is no tutorial, but from the next week, we are going to have the tutorials. Okay, so for the tutorials, most of the content have already been uploaded to Blackboard, as I have already said. Okay, so you can watch the videos, but do prepare your own headsets, okay, headphones here. Yeah, so during the tutorial, if you have any questions, feel free to ask me or the TAs. Okay, the TAs will also be here during the tutorial time. And of course, we have 2-hour lecture per week, okay, from 7:30 to 9:20. The venue, of course, is here. Everyone is here. So yeah, there is no need to go through the room numbers. For the assignment, which is very important, okay, so we have one individual assignment, okay, so for this individual assignment, you have to do it individually, okay, which is very obvious. We are sorry, it's around the assessment will be 10%, okay, 10% of your total assessment, okay, so you are going to have 100 points, okay, 10 points for the individual assessment. The second one is the in-class test, which is a closed book test, because from this semester on, we need every subject offered by computing will have an element that has to be done in the closed book form, okay? Either in classroom or in other forms, okay? But it has to be closed book, okay? So yeah, so there will be an in-class test closed book, which will be 20% of the total score. We are going to have the group project, okay? So for the requirements, you can refer to the documentations on Blackboard, okay? So for the group project, it will be 25%, okay? 25 points out of 100. So it will be divided into 4 phases, okay? So each phase will have its own theme and also the tasks you are going to complete, okay? So for example, for phase 1, you are only going to have the VR game design documentation, okay? So for the detailed requirements, you may refer to the document I have already uploaded to Blackboard. So for phase 1, for example, is 3%, okay? For phase 2 is mainly about implementation, so the weight is a little bit higher, is 12%. For phase 3, we are going to have the trial play and the evaluation. Okay, for the evaluation methods, we will also cover some of them in the later lectures. Okay, so we expect you to apply those methods you've learned and then to complete the tasks in phase 3. Okay, so phase 3 is 4%. Okay, so lastly, we also need you to write a very short report and also do the presentation. Okay, do the presentation. So yeah, this will be 6%. Okay, 6%. And also the presentation will be delivered in the last week, week 13. Okay, week 13. Yeah, and also the final examination, which is 45%. 45%. Okay. So any questions about the assessment? Okay. Any questions? Okay, so if no questions, let me move on. Yeah, another very important thing is about using ChatGPT. Okay, so for the first time when I delivered this course, there is no such kind of thing. There is no ChatGPT, no generative AI, etc. But now, generative AI is really taking off, and a lot of students, as far as I know, are using it for assessment. Okay, so PolyU has a university-wide policy. Okay, so you can go and have a look. Okay, basically, you can use GPT and also other generative AI tools for completing the assessment. Okay, for completing the assessment. But there is a subject-wide policy. Okay, so first of all, you have to follow the university's guideline. Okay, the second thing, which is also very important, you are the person who is responsible for the submissions. Okay, not ChatGPT or generative AI. Okay, so this may happen very rarely, but you know that ChatGPT may make some fake references. Okay, so if you submit such kind of things, then I will treat you as an irresponsible person. Okay, you have to check whether the GPT or other generative AI models give you some factual things. Okay, not some hallucinations. Okay, so this is very important. So check, yeah, the contents generated by the generative AIs before you submit. Otherwise, I can only blame you. I cannot blame ChatGPT, right? Okay, so for a textbook, it's very straightforward. You do not need to buy it. It's free. You can go online and download it. Okay, but not everything covered in this lecture will be covered in the textbook. Okay, and the same thing applies to textbook. Not everything covered in the textbook will be covered in our lecture. Okay, so we only evaluate you based on the topics and also different themes we covered in the lecture, not the textbook. Okay, so this is very clear to you. Yeah, so if you are interested in a particular topic, so for example, if you are really interested into spatial user interface, you can go and check this book called the 3D User Interface Theory and Practice. Okay, the same thing can be applied to other aspects and topics covered in this subject. So for example, if you are really interested into human perception and sensation, you can go to Foundations of Sensations and Perception. Okay, all the textbooks can be borrowed from our library. Okay, all the textbooks can be borrowed from our library. Of course, it has a very limited number of copies. Okay, so always first come, first serve. Okay, next I move to the outlines of the lecture. Okay, so this is the first lecture. So I have to tell you what we are going to cover in the next 13 weeks. For lecture 1, we are going to give you a very brief introduction to extended reality. Okay, this may include, for example, the definitions of extended reality, historical context of VR, AR, etc., interdisciplinary nature. Okay, so these topics will be covered in week 1 and week 2, which means this lecture and also the next lecture. Okay. Lecture 2, perception, cognition, and psychology. Okay, so of course, I'm not going to talk about, for example, the subject called Introduction to Psychology. Okay, but still, I will talk about things that are related to psychology, cognition, perception in week 3 and week 4. So, for example, depth perception, color perception, etc. Okay, so these are very important for you to deliver the we call it a good experience in XR. Okay. We will talk about some illusions. So for example, the rubber hand illusion, the sense of embodiment, etc. Okay, in lecture 2. Lecture 3 is about the spatial user interface. Okay, so this is very important because, for me, I'm often invited to, evaluate some of the applications for startups, for some, well-established companies. But I found that in many cases, their user experience design is not very good. The user interface may not be that convenient for people to interact with their VR contents. Okay, so this is also a very important topic if you want to develop your own XR applications. So we are going to cover, for example, universal simulation theory, user experience design in XR, cyber sickness, which is a very, very important topic. Okay. So I have a lot of collaborations within the campus. So for example, some professors from School of Nursing, from School of Design, they may contact me to do a collaborative project, research project. Okay. So every time when I mention virtual reality, they will ask me, hold on a minute, will it be suitable for people to use? I used the virtual reality before and I really feel sick. Okay. So these are all about cyber sickness. Okay, so we will talk about cyber sickness and see how the experience can be, some experience can be designed to mitigate cyber sickness. Virtual locomotion is another very important topic because virtual reality basically gives you an infinite amount of space for the users to explore, right? But in reality, the users are still confined to a physical space. Okay, the physical space is of course limited in terms of the size. Okay, so you have to find a way for your users to navigate in an infinite large space. Okay, while being confined to a limited physical space. Okay, so this is about virtual locomotion. Of course, we will talk about other topics in lecture 3. Okay. Lecture 4 is about visual rendering and multisensory XR. Okay, so I think many of you are very familiar with rendering already. Okay, so if you graduated from CS, okay, you got a bachelor's degree in CS, perhaps you have already completed computer graphics course in your last year, okay, year 4. So yeah, but I know that there are students from have a design background and also maybe some other interactive media background. So you may not fully understand what computer graphics is and how the graphics things can be rendered to headsets, okay, virtual reality headsets. So we will briefly talk about that, and I will also use this opportunity to talk about multisensory XR, okay, which is a very important research topic for me, okay. So I've been doing multisensory XR for quite a while. Lecture 5, XR application design and development. Okay, so this particular subject has some overlap with software engineering. Okay, so if you have some backgrounds, for example, working in the industry, develop some software systems, even not XR system, you will know this topic quite well. Okay, but we will still talk about some related topics. So for example, what is application domains? Okay. And also how to do prototyping and testing for XR applications. Lecture 6 will mainly focus on applications and evaluation. Okay, so application and evaluations is a very important topic for XR developers. Okay, so in many cases, after your graduation, you either work for a large company or you start your own business. Okay, so I know many of the students, even undergraduate students, after completing some VR, XR, AR training, okay, at our department, they start their own business in Hong Kong. Okay, so yeah, so you most likely you are going to develop the XR application for someone else to address a certain problem. Okay, in this case, you really need to have an evaluation method to see how your program can actually address this issue. Okay, so for example, you are hired by someone running a museum, for example, and the museum owner wants to ask you to develop an XR application for the museum to show their potential, visitors, what they are going to see in the museum to attract more visitors, right? So this is a very straightforward business. So how can you evaluate that? How do you know your XR application can actually help the owner to achieve the intended results? Okay, so this is what we are going to cover in lecture 6. Oh, by the way, lecture 6 will be covered in week 8 and 10. Okay, we are going to have the in-class test in week 9. Okay, week 9. The last lecture will be lecture 7 about the latest trends and challenges. Okay, so we'll, for example, we will talk about social VR and metaverse. Okay, I guess this is why you are here, right? You are all interested in metaverse. We will also talk about haptic rendering, XR plus AI. Okay, this is also a very hot topic. Okay, I will use NVIDIA Omniverse, and I will see if I can invite someone from NVIDIA to actually deliver some of the topics. Okay, so yeah, body swapping and sense of embodiment, XR experience for social thinking and behaviors. Okay, so these are all different topics we are going to cover in the last lecture. But note that the actual content may change because XR is developing so fast. Okay, so for example, I almost update the entire set of slides for lecture 7 every time I give this course. Okay, because everything is just developing so fast. Yeah, I have to just update. So any questions about the topics of the lectures? Okay, so let's move on to tutorial part. So for the tutorial, I won't spend too much time talking about this. I just want to let you know that I have already recorded video. So if you are not very comfortable doing some, for example, VR programming or even programming in Unity, you should watch the video very carefully. Okay, the video will tell you almost every step for you to develop an XR application. Okay, although it's I would say a simplified version, okay? Because there are just so many different functions in Unity, I cannot cover them all, okay? And also, I don't think I need to do so because even you go to YouTube, you search for tutorial, Unity tutorial, you will find a lot of videos, okay? I just cover those that are related to XR, okay? Related to the function of XR. And for the tutorial videos, we use in VR, okay? And also in the demo, if you have already watched the video, you will notice that I use the HTC Vive to actually record the video, okay? So you are going to have some Oculus Quest, which you can borrow from our technical team. I will talk about the checking out of the equipment later on, okay? But the beauty of Steam VR is that it is compatible with multiple brands or models of VR headsets, okay? So even you want to deliver your final product to Oculus Quest, you can still follow the entire procedure I made using HTC Vive, okay? Yeah, so that's about the tutorial. Again, week 9, we will use the time to do the in-class test, okay? So the in-class test will be 2 hours, okay? Will not be 3 hours, but our TAs will check your student IDs, okay? And also we will distribute the papers, okay? The exam papers, the in-class test papers, okay? So it will take some time. So that's why we will also use the tutorial time to, just handle this type of things, okay? Yeah, so let me start this lecture by talking about the goal of the subject. Okay, so this is very important because after you finish this, you should, feel a sense of fulfillment for yourself. Okay, the goal of the subject is very straightforward: equip you with necessary knowledge and skills to make good XR experiences. Okay, so but the problem is that how do you define good? Okay, so I guess many of you who are from mainland China, okay, just like my background, okay, we are always told by our teachers to say that you should be a good student, right? But every time your teachers ask you to be a good student, you always have a very puzzled head. Okay, what do you mean? Right? What do you mean by saying a good student? Okay, for our subject, it's very straightforward. Okay, we define good as comfortable plus adequate. Okay, comfortable and adequate. Okay, so for example, if you introduce a lot of cyber sickness to your users, of course the experience is not that enjoyable, right? So this is not a good application. Okay. On top of that, we also need to make adequate functions and adequate details to the rendering in order to help the users achieve the intended outcomes. Okay. So for example, here we have two different applications. One is made by Valve, I guess. Okay, it's called Half-Life Alyx. This is I think the most famous VR game. Okay, nowadays. If any of you have ever played Half-Life Alyx before, okay, 1, 2, anyone 3, okay, you should try it. Okay, if you want to be an XR programmer, you should try it. Okay, there are just so many little detailed design decisions Valve made in making a Half-Life Alyx. Okay, so every time my students come to me to see how should I make this spatial user interface, I said check Half-Life Alyx and see if it has already been implemented. Okay, this is my answer to them. Okay, this is how good this game is. Okay, it's not only about the game content, it's about the user experience, user interface, etc. Okay, and also the simulation of the physics is just fantastic. Okay, so on the other hand, we have Mozilla Hubs. Okay, so this is a social VR application. Okay, so it's very similar to, for example, VR Chat, Rec Room, Outer Space, which has already been discontinued by Microsoft, which is unfortunate. Okay, but as you can see here, the graphical impression, okay, if you look at these two games, okay, the visual impression to you can be quite different. Okay, Half-Life Alyx has a lot of details, right? Has a lot of details. But on the other hand, for the social VR application, Mozilla Hubs, it has much fewer details regarding the rendering, the visual fidelity, right? So all the things seem to be very low polygon, okay? So this is just for, because it is a social VR application, you have to download all the content from the server, okay, in order to enjoy the experience, okay? Half-Life Alyx is around 20 to 30 gigabyte, okay, for the entire game, okay? You cannot imagine that to enter this space, a social VR space, you have to wait for 1 hour to download it, okay? People will just close it, right? We are not trying to do it. So that's why I said adequate. Okay, adequate is very important. If you are designing a VR application for socialization, okay, low polygon visualization, low polygon style, visual style is good enough for this purpose. Okay, but on the other hand, if you really want to make a very immersive game, okay, VR game, you have to think about this. Okay, especially when people are so getting used to the AAA games nowadays. Okay, so a lot of companies just spend, millions, even billions. Okay, for example, if we are talking about Starfield, okay, or Baldur's Gate, okay, which is very, very popular nowadays. Okay, these games will on the development cost will be on a billion level. Okay, billions of dollars level. But of course, it depends on your application. So as long as the applications, functions, and also the visual rendering, the fidelity is good enough for your application, then we call it adequate. Okay, this will be applied also to when we assess your good project. Okay, as long as it's adequate enough. Okay, I feel the game is interesting to play. That's it. That's good enough. Okay. So do not try to spend a lot of time making the visual details of your VR games. Okay, it's not very important. Okay, it's not very important. We will not mark your assignment, the good project, based on the visual fidelity. Okay, so yeah. So any questions for this? Yeah. Okay, so let's move on to have a look at cyber sickness. Okay, so I have already mentioned about this. So cyber sickness is a thing that we have to avoid when we design the XR experiences. Okay, so what is cyber sickness? Well, cyber sickness is a cluster of symptoms that occur in the absence of physical motion. Okay, similar to motion sickness. Okay, very interesting. Okay, so people ask me. Okay, so I feel really dizzy when I ride on the roller coaster. Okay, so can I say I experienced the cyber sickness based on this definition? Yes or no? Yes. So anyone said yes? Hands up. Yes. Anyone? No? No? Okay. So for other people's opinion is I don't know. Okay. So based on you are right actually. Okay. So the sickness you experience when sitting on a roller coaster cannot be called cyber sickness. It's called motion sickness. Okay. It's caused by motion. It's not caused by the absence of motion. Okay. If it's caused by absence of motion, it is called cyber sickness. Okay. So yeah, why cyber sickness occur? Okay. So there are many theories to explain this. Okay, there are two very important theories. One is called sensory conflict theory, as we have already put it here. The other one is called postural instability theory. Okay, so that one is a relatively new theory. Okay, relatively new theory, and it used to explain motion sickness, but people find that it can also be used to explain cyber sickness. Okay, but I will put that away because we will have this topic discussed in the later lectures. Okay, but now I just want to briefly introduce you to sensory conflict theory. Okay, which is very straightforward. You have your vestibular system. So vestibular system is the the system for you to control your balance. Okay, you can stand up without falling down. This is simply because of your vestibular system. Okay, so the vestibular system has a very interesting structure. It has 3 different channels. Okay, so in each channel there is fluid. Okay, there is fluid, and this channel can sense the movement, the motion of the fluid within your inner ear. Okay, so vestibular system is in your ears. Okay, is in your inner ears. So when you move, so for example, if I jump, of course, the fluid will drop to the bottom of these channels, right? So the vestibular system can sense that and seeing that, okay, what is going on? You are going up, right? So that's the response from the vestibular system. Okay, it can sense up and down, left and right, forward and backwards. Okay, so basically it can track your balance within the 3D space. Okay. The other one, the that we use, the other sensory channel that we use to control our balance is of course the vision. Okay, so we see the horizon. Okay, so that's why we use this to actually control our balance. However, in this case, the man is seeing is using the VR, and the VR content is a roller coaster experience. Okay, so his eyes are telling him that he is really moving fast on a roller coaster. Okay, but on the other hand, the vestibular system did not detect any motion. Okay, in the 3D space. So this is where the conflict happened. Okay, so that's why he may feel cyber sickness. Okay, I use may because different people may have different tolerant level. Okay, so some people are really, really tolerant to cyber sickness. Okay, so he may experience cyber sickness. Okay, but I would say that for ordinary people, you have a very large chance that you will experience cyber sickness. Okay, so that is the sensory conflict theory. Okay, and how to use sensory conflict theory to explain cyber sickness. Okay, so any questions? Okay, so let's move on. So another thing that I want to talk before we dive into any details of the lecture is about the R's, okay, the realities. So perhaps you have already heard about virtual reality, augmented reality, mixed reality, extended reality, right? So the name of the subject is called extended reality. Okay, why is it like so? Okay, first of all, I just want to introduce you to this spectrum. Okay, so this is so-called virtual and the physical spectrum. Okay, on the left-hand side, we have the reality, the real physical reality. Okay, on the right-hand side, we have the virtual reality. Okay, which is totally virtual. Okay, which is totally virtual. So somewhere in the middle, we have the augmented reality. Okay, so it is very easy to understand, right? Either it can be a mobile AR or optical see-through AR. It doesn't matter. Okay, so we blend reality with something virtual. Okay, so you all played Pokemon Go before, right? So Pokemon Go, have you ever played this game, AR game, right? So that game is called an AR game. Okay, you can toggle the AR mode and turn it off, right? So if you turn on the AR mode, it will use the camera, your phone's camera, to capture the reality, right? And then the Pokemon will appear somehow in front of the camera, what has been captured by the camera, right? So you have the feeling that the Pokemon is standing in front of you. Okay, so this is a blend of something virtual and something physical. Okay, of course they are all fake, right? So even for the background is captured by your camera, by your phone's camera. So it is a virtual scene. Okay, it's a just a PNG file, for example, right? It is still virtual, but anyway, it's a blend of the physical world with the virtual world. Okay, so that's why it's called AR. So it is even true for HoloLens, Microsoft HoloLens. You have the optical see-through. You can see everything that is happening around you, right? But still, you can see the virtual things floating in front of you. Okay, so this is AR. It is somewhere in the middle of this spectrum. Okay. How about mixed reality? How about mixed reality? Okay, you can treat MR as an extended version or extended concept to AR. Okay, mixed reality to augmented reality. Okay, so normally when we say mixed reality, normally users will have a control regarding how the physical world will be blended with the virtual world. Okay, so anyone have ever tried Apple Vision Pro before? No, not really. No, no one. Okay, I have a student last year who went to the WWDC with me. Okay, so we tried the Apple Vision Pro there. Okay, so it has a digital crown, which is very similar to my Apple Watch. Okay, you can dial this digital crown and adjust how the virtual thing will be merged with the physical world. Okay, of course, the physical world again is captured using the cameras. Okay, and also sensors, different types of sensors. Okay, so you have the control. So that's why it is always just picking the point on the spectrum. Okay, so if you really dial this digital crown, you will be fully immersed in the virtual world. Then it becomes VR, right? So if you dial it really to the other end, you will find that you see everything that is super realistic, but you can sense that it's still captured by the camera. Okay, so you can pick any point on this spectrum. Okay, so that's why it is called mixed reality headset. Okay, so yeah, so that's it. That's mixed reality. Last one is extended reality. So extended reality can be considered as a mixed reality plus virtual reality. Okay, so that's it. So any questions? Any questions? Okay. So we move on to the next slide, XR design. Okay, so you will hear about XR design or virtual reality design, augmented reality design a lot within this subject. Okay, so when we talk about XR design, we are talking about basically three different things. Okay, so the first one is environment. Okay, so environment can be quite tricky. Okay, so if we are talking about VR design, then we are talking about a purely virtual environment. Okay, if we are talking about XR design, it's a mixture of physical environment and the virtual environment. Okay, so that's why last time, a local company showed me a AR goggle. They call it AR goggle. Okay, so they showed me, and I told them, no, you are not making AR goggle. It's just a display. Why I say so? Why I say so? Okay, because there is no interaction between the physical environment and the virtual environment. Okay, why it is like so? Okay, so if you ever tried HoloLens before, okay, you will notice that actually HoloLens has the ability to sense the environment in 3D. Okay, so for example, I have something. Yeah, maybe this pencil. Okay, so this is a virtual one. Okay, you treat it as a virtual one. Okay, it is a virtual pen. Okay, so the pen is floating around here. Okay, it's floating around here. So if it is true augmented reality, I can see this, right? And I can also see what is going on around me in the physical world, right? This is very straightforward. Okay, everyone tried HoloLens or tried Google Glasses before. Okay, can understand this. Even you've ever tried Meta's Quest Pro or Vision Pro, Apple's Vision Pro, you can understand this, right? But the tricky thing is that as I move forward, the pen will either fix here or move with me. Okay, so can you understand the difference? Okay, so in one case, the pen is always keeping a relative distance, a constant relative distance to me. Okay, so in this case, I have the doubt that whether this headset has a so-called 6 degrees of freedom, whether this headset can sense I'm going forward. Okay, so you can imagine if this is a monitor, it is supposed not to move, right? So if I move forward, the monitor will not move. It will be here, right? So this is a true AR experience, right? But if the monitor is also moving, with me and then floating here, right? Then it is a fixed thing, right? So this is simply because the headset may lack the property or the ability to track my location within this 3D space. Okay, so this is one problem. And another problem is that, imagine this is still the pen, okay? The pen is floating here, okay? But the next time when I start the program, I stand here. So the pen is floating here, right? But my vision is blocked by this physical monitor, right? So I should not be able to see the pen, right? So if it is true AR, right? So these are two levels, okay? So the first level, as I mentioned, the monitor should not move with me if it's a virtual monitor, okay? So this is level 1 AR. It means that the headset should be able to sense my motion, right? To achieve the second level, okay? To achieve the second level, the virtual pen will be blocked by this monitor. It requires the second ability of the headset. That is the understanding of the physical environment. Okay, it has to sense this is a physical thing. It will block my vision, right? If it cannot do so, then it is not a true AR experience. At least it is not the so-called level 2 AR experience. Okay, so is that clear to you? Okay, so next time we'll try different AR headsets. I know there are lots of different AR headsets now. Okay, try to do this, try to make this trick. Okay, make something virtual, okay, in front of you and try to move and see if this virtual thing will move or not. If it is moving, then it is not even achieving the first level of AR. Okay, for the second level, you can do the same thing. Okay, you draw something or you create something behind a physical obstacle and see if it can be blocked or not. Okay, so very few headsets can achieve the second level of AR. Okay, to be honest. Yeah, it requires special hardware and also software to understand the physical environment. So that's why when Apple released the so-called Vision Pro, they used a word called spatial computing, right? You heard about this before, spatial computing. Okay, so this particular term is used to describe how the headset can understand the environment. Okay, so I tried this on Apple's Vision Pro, and it can actually achieve that. which is amazing. Okay, level 2 AR. Okay, so yeah, so that is the interaction between the physical environment and the virtual environment. Of course, it's limited by the ability of your headset. Okay, but within these limitations, you have to think about this. Okay, so that's the first component of XR design. Okay, the second component is called interaction. Okay, so interaction can also be categorized as explicit and implicit interaction. Okay, implicit and explicit interaction. How I depict that? Okay, still I will use this pen here. Okay, maybe I use a bottle, so it will be larger. Okay, so the bottle is here. Okay, so now the XR application asks me to have a detailed look of this bottle. Okay, so for example, you can imagine it is a game. Okay, I have to find a lot of details in order to, for example, escape from the room, for example, right? So now the game gives me a hint that there is something wrong with this bottle of water. So I have to have a more detailed look. Okay, so what should I do? What should I do? I either do this, right? Or I pick it up and have a look, right? Right? So everyone will do that, right? So this is very straightforward. This is actually called implicit interaction. Okay? Implicit interaction is what we do when we are asked to perform some actions without even thinking about it. Okay? We are not even conscious that we did that, but we did that. Okay? So I want to have a look, so I just pick it up to have a look, or I just become closer to the bottle and have a look. That's it. Okay? And the same thing. So for example, the game tells me that you have to move to this position. Okay, so I just move to this position. I walk to this position. That's it. This is also explicit interaction. Okay. So how about the other? Okay, how about the other? So yeah, so sometimes remember, if we are talking about explicit interaction, we have to give users very clear instructions. Okay, so for example, the game tells me that you have to pick up this bottle of water, place it here to unlock something. Okay, so this is something that has to be the instruction has to be given to me in a very clear way. Okay, otherwise the bottle can be placed here, can be placed here, can be placed here, right? I don't know. If you just give me an instruction saying that you move the bottle, which is super unclear, right? So I can move the bottle anywhere, right? So this is not the way we do it. Okay, if this interaction is explicit, remember, you have to give user very clear instructions. Okay, if it's implicit, for example, move to this spot, you don't need to give users very clear instructions. Use your right leg first, left leg. You do not need to do so, right? Just walk there. That's it. Okay, just have a look, right? That's it. Okay, so remember, yeah, in your XR application design, okay, if you want to have some explicit interactions, give clear instructions, okay, based on the cognitive ability of your users. Okay, so for example, I did a lot of VR applications for children. Okay, so you can expect that if I embed a lot of explicit interactions in my application, then perhaps I should give even more detailed instructions, right? So if you are designing an XR application for older adults, even with, for example, cognitive impairments, okay, you should think about this. Okay, you need to give very detailed interactions. But for implicit interactions, you may skip that. You may skip that. Okay. So this is about interaction, and the last part is about different objects within the scenes. Okay, within the environment. So for example, avatars. Okay, so if you are really interested into metaverse, you know that avatars are quite important. right? So you use avatars to represent yourself in social VR applications. You also interact through your avatars with other people's avatars in metaverse, right? So avatars are super important. I have a recent research on different, gaze patterns and also, facial expressions, and how these, facial expressions, gaze patterns can affect people's perception of other people within metaverse. Okay, so that's why avatars are super important. And the ordinary way of doing this is through a customization process. Okay, so for example, you can ask the user to pick skin color, body shape, whether it's a female avatar or a male avatar, the different hairstyles, whether the avatar should wear glasses, things like that. Okay, so this is called avatar customization, which is a very important step to induce the so-called sense of embodiment. Okay, so notice that sense of embodiment. I just mentioned about this when I introduced these lectures. Okay, sense of embodiment is super important. You believe the avatar is your avatar. You believe you are inside the avatar. Okay, so this is called sense of embodiment. So avatar customization is a way of doing so. Other ways, for example, photogrammetry, to have a 3D scan of your own body, okay? And then we just import that body, that virtual body into different XR applications, okay? These are all the different design decisions you have to make, okay? Even in some applications, you do not need an avatar, especially for AR applications, okay? For AR applications, I can see my own hand. So why do I need an avatar? I don't need an avatar, okay? But if it's a collaboration, okay, remote collaboration AR application, okay? So for example, I collaborate with this student, okay? He's also wearing a AR headset, for example, Microsoft HoloLens, okay? It's very important for him to see me, right? So in his headset, I have to present myself as an avatar, right? In my headset, he has to represent himself as an avatar to me, okay? But for myself, I do not need to see my own avatar because I can see my own hands. I can see my own body, right? So that's it. Yeah, so these are all little decisions you have to make, okay? First, do you need an avatar? Do you need an avatar for the local user? Do you need an avatar for the remote user? Okay, and if you need an avatar, does it need to be super realistic through a 3D scanning process, okay, to create these virtual avatars? Or it can be done through a simple avatar customization process. Okay, so these are all little decisions you have to make based on your application. Okay, remember, adequate. Okay, of course, every time we can do something that's super realistic, but it's not, necessary in many cases. Okay, so adequate. Data, of course, all the things, the avatar, the environment can be data, and also you can visualize data inside XR applications. Okay, so yeah, and also data is not only about data output; it's also about input. So, for example, how do you type in VR? Very difficult, right? You have to use a pointer to point to a QWERTY keyboard, and then you just press the trigger and then enter the letters one by one, which is a very clumsy procedure, right? So yeah, so if you have any good ways to enter data, okay, either it can be just the letters, words, or something else, for example numbers, okay, it should form a very good research topic actually. Okay, even for some applications, you need a lot of ways to enter data. Okay, so yeah, you should think about this. So all these three different components can be called content. Okay, content. So next time, okay, so maybe after your graduation, you decide to start your own studio doing XR development, okay, in Hong Kong, just like some of my previous students. Okay, when people tell you that you have to develop a VR content for me, okay, you should ask the question, what types of environment you ask me to build, okay? What are the interactions you are going to build? And also what are the objects you are going to have within the environment? Okay, so 3 different questions. Okay, so any questions about this slide? Okay, so before I move on to the definition of XR, let's have a 10-minute break. It's 8:20, and we will resume the lecture at 8:30. Okay, 8:30. Okay, so it's 8:31. So please take your seat and we will resume the lecture. Okay, so yeah, during the break, I think a lot of you asked me about borrowing the Oculus headsets from the technical team, right? So our guideline is that every team, every project team, okay, can have up to 2 sets. Okay, so if you have already read the a project description, you will find that I will give you a bonus if your application has a networked element. Okay, so for example, it's a multiplayer game. Okay, you will have the bonus. So that's why I will let you to borrow up to 2 headsets. Okay, so for each group, just in case you want to get this bonus and make the experience a networked experience. Okay, so if you have already borrowed that, it is fine. Okay, but remember we have a very limited amount of headsets. Okay, so if your group has 3, which means that another group may have just 1. Okay, so if you borrowed more than 2 for your group, okay, just return it to the technical team. Okay, where you got the headsets. Okay. Yeah, so let's resume the lecture. Later I will send an announcement just in case some of you are not here today. Okay. Okay, so let's resume the lecture. So next part, I'm going to spend some time to discuss what is virtual reality. Okay, so as I mentioned, it is very mature. Okay, it has been around for I think over 60 years already. Okay, so that's why this particular domain of knowledge has already been really well defined. Okay, so it is not something new. So that's why we use virtual reality to study XR. Okay, instead of using more um, latest but may not be that mature terms. Okay, so for example, mixed reality. So if you search virtual reality on Google, you will find that some pictures like this. Okay, the left one. Okay, headsets. And some of you may even find the pictures like the one on the right. Okay, some large curved displays. Okay, projection screens. So does it mean that virtual reality equals to displays and screens? Well, of course it is not, right? So that is why we have to define virtual reality. Okay. So this is the definition of VR from our textbook. Okay, Laville's virtual reality textbook. Okay. So the definition is inducing target behavior in an organism by using artificial sensory stimulation while the organism has little or no awareness of the interference. Okay, so this is a very good definition of VR. Okay, why I say so? Okay, I have already highlighted some of the words. So for example, behavior, organism, artificial sensory, and no awareness. Okay, so these are the keywords. Why it is like so? Well, first of all, let's have a look at target behavior. Okay, so the organism is having an experience. Okay, so that's why I'm always talking about user experience, XR experience, virtual reality experience, right? So we are talking about experience. It's not about the content. Okay, it's not only about the content. It's about an experience. Okay, so the organism is having an experience that was designed by the creator, designed by you, right? So if you are the designer of the XR experience, then it simply means that the organism, a user, is using your experience, is experiencing your experience, right? So examples include flying, walking, exploring, watching a movie, and socializing with other organisms. Okay, so the last one, of course, means social VR, right? So yeah, so that's the targeted behavior. Okay, still remember the explicit interaction and explicit interaction, right? So for these interactions, basically, these are the target behaviors you want your users to experience, to behave, right? So that's why you have to give very clear instructions. Okay, so this is the target behavior. Organism, okay, this could be you, someone else, or even another life form such as a fruit fly, cockroach, fish, rodent, or monkey. Okay, so yeah, so basically, scientists have used VR technology on all of this. Okay, later on we will see an example. Okay, So in general, basically, if we are not talking about some extreme cases that we use animals to do VR research, okay, then basically organism simply means your users, okay. Artificial sensory stimulation. This is also very important because everything is just virtual for virtual reality, right? So yeah, through the power of engineering, one or more senses of the organism become co-opt, okay, at least partially. And their ordinary inputs are replaced or enhanced by artificial stimulation, okay? So for example, when you wear the headset, you listen to the sound made by the speakers, right? Your vision is totally blocked by the headset. What you see is just something artificial, right? So this is called artificial sensory stimulation. In the next lecture, okay, not next week, but the next lecture, okay, we are going to talk about sensory stimulations, okay, sensations, perceptions, okay. So this is just to give you a very brief glimpse towards the definition of VR, okay. The last one is also very important, awareness, okay. So I would say that in an ultimate virtual reality experience, you would not be able to tell whether you are experiencing is real or fake, okay? Whether it is a real thing or something artificial, okay? There are lots of such examples in sci-fi movies. So yeah, for example, Westworld. Anyone watched that series before? Westworld, okay? So you cannot tell if it's a robot or not, right? Some of the avatars within that, that park scene, okay? So you cannot tell whether it's a robot or a real human being, okay? So yeah, for VR, we also have some, examples. So Star Trek, okay, maybe it's too old for you, for your generation, okay? So Star Trek, in some of the series, they have a technology called holodeck, okay, which are space that they can use energy to create some objects and even avatars. Okay, you can interact with these avatars because artificial intelligence is a very common thing in the near future. Okay, so even you can imagine that I build a super realistic avatar and use ChatGPT to drive it. Maybe you cannot tell whether you are talking with a real human being, okay, or just some robots, right? So yeah, so this is about awareness. The higher the higher the visual fidelity, okay, and also other artificial sensory stimulations, the less you will be aware that you are in a virtual world. Okay, so those are the 4 very important keywords about Laville's definition of VR. Okay, so any questions? Okay, so next time, if you are asked by people what is VR, use this definition. Okay. Okay, so this is an experiment I just mentioned. This is a very extreme case, a VR for a cockroach. Okay. How can people do this? Okay, so let me just play this YouTube video, okay, for you. So can you see it? Yeah, so this is actually something that people use to, as I hate YouTube ads. Okay, so this is something that people made to investigate how these, virtual reality system can be used to study the behavior of some insects. Okay, so why we design this and why it can be called a virtual reality system? Okay, so if we go back and see whether the 4 elements are there. Okay, so for example, targeted behavior. So the insect which is mounted on this sphere has these targeted behaviors because we make a more like a maze, okay, for the insect to navigate around. Okay, so the targeted behavior is very simple: walk, okay, or navigate. Okay, so that's it, targeted behavior. Then what other one? Organism. Okay, of course, a cockroach is an organism, right? Artificial sensory stimulation, yes, because there is a projector here. Okay, so we use this fisheye lens to actually project these scene that for the cockroach to actually see. Okay. Yeah, and also for the cockroach, for the artificial sensory stimulation, the cockroach has nowhere that he's always standing on top of a sphere. Okay, so the sphere will react to its movement, right? So yeah, so this is also artificial sensory stimulation. Okay, just like you run on a treadmill, for example. Okay, so the treadmill will give you the sense that you are actually running in the physical space, right? But it's actually you are stationary, okay, in relative to the 3D space. The last one is awareness. This is very hard to tell. Okay, I don't know whether the cockroach can sense that, but it seems that yeah, it can behave just like it has no awareness that he's living in a virtual reality space. Okay, so yeah, so this is a very extreme case, but this is not okay. So basically, this man is a cockroach. Right? So he's he's actually let me play it again. Okay. So basically, he's standing on this treadmill, and then you can just wear a very specialized slipper and then walk, even run, jump on this platform. Okay, and he has nowhere. He basically thinks that he's actually moving in this 3D space. Okay, but of course he's not. Yeah, so yeah, I just want to have a very simple discussion here. So in the Veil's definition of VR, it says that in inducing targeted behavior in an organism by using artificial sensory stimulation, while the organism has little or no awareness of the interference. So are the following is virtual reality? So reading a book, is this virtual reality? Is this virtual reality? No? Why? You are quite aware that you are reading a book, right? So yeah, so that's not. Watching a 3D movie, is that virtual reality? No? Okay, why? You are still aware? Using the same reason again? Okay. Talking with someone over phone, is that virtual reality? No? Okay. Playing World of Warcraft with friends? Yes. Some people say yes, some people say no. Okay. Using TikTok? Okay, the same thing applied here that book, 3D movie, phone, telephone, online games, multiple user online games, okay? And TikTok, which is a social media, I would say, okay? They are all different types of media, okay? So the discussion will be based on the assumption that virtual reality is also a medium, okay? Is also a medium. So why I say so? Okay, why I say so? So this is not from something else. This is actually from a paper, a journal paper that has been published in a Journal of Communication, which is the top tier journal of media and communication, basically. Okay, so this paper was originally published in 1992. Okay, discussion the definition of virtual reality. Okay, as you can see here, all different media can be placed on top of this 2D plane. Okay, on the horizontal axis we have the interactivity. On the vertical axis we have vividness. Okay, so we can place different medium on top of that. So for example, book has basically no vividness, I guess. Okay, so it depends on your imagination, right? So yeah, but there is no interactivity, right? You cannot interact with others. You cannot interact with the medium. You cannot interact with the writer, right? So there is no interactivity there. Movie and also 3D movie, they are more vivid, but still you do not have interactions with the director, for example, with the writer again, right? So video games, of course, they have a higher level of interactivity. right? You can interact with different objects within the virtual environment, as we mentioned. You can also, in the case of online games, you can also interact with other players, right? So games have higher interactivity. Then how about virtual reality? How about virtual reality? As I mentioned at the very first beginning, one very important thing for good XR experience is it's adequate, right? Which means that you do not need to have the ultimate vividness. You do not need to have the ultimate interactivity. It depends on the needs, okay? The user requirements. So that's why I prefer to draw a very large circle here, okay? So virtual reality covers a great area on this 2D plane, okay? On this 2D plane. But people may ask, where is the boundary? Okay, so for example, for these four, I guess a lot of people say no, no, no. But when I ask people, is playing World of Warcraft with friends virtual reality? Some people say yes. I heard someone said yes here. Okay, so it simply means that the boundary is really blurry. Okay, so maybe you place, World of Warcraft here. Okay, online games, right? But if this boundary is a little bit larger, you will think that playing World of Warcraft is also virtual reality. Okay, but there is no solid boundary here. Okay, so if someday, maybe next year, maybe 10 years later, okay, Blizzard decided to make a VR version of virtual reality, World of Warcraft, then it is virtual reality. You just need to change one thing, the perspective and also the device, right? World of Warcraft is a third-person perspective, which first we change it to first person, right? The second thing we need to do is not play it on an ordinary monitor. We play it in VR headset, which I guess will be very popular by then, right? So then it is virtual reality, right? Everyone will say that it is virtual reality. We didn't change the content too much. We just changed the perspective plus the interaction device. That's it, okay? It becomes virtual reality. So the boundary is really, really blurry here, okay? It's really hard to say. Yeah, but still we have the ultimate examples of virtual reality. I have already mentioned about this. So for example, in the sci-fi movie Ready Player One, the main character can actually enter this virtual world through these devices. They have we already have the headset. We just do not have the harness system to let you feel the bullet hitting you. Okay, and also the climbing, the forces. We do have some devices. Later on, when we talk about multi-sensory XR, I will talk about those devices. Okay, but largely they are in the labs. Okay, not in the mass market. Okay, and also on the other hand, we have the holodeck. Okay, so the message I want to deliver is that VR makes you feel being there in the virtual world. This is the very important thing. Okay, you feel like you are inside there because of the interactivity and the fidelity of the medium, which is also called vividness. Okay. Yeah, so speaking of the sense of the feeling of being there, okay, we have a term actually talking about this. It is called presence. Okay, it is called presence. So as you can see here, we have already introduced Laville's definition of virtual reality, which is published in 2016. Okay, but earlier in 1992, just as I mentioned in the Journal of Communication, Jonathan Stewart has already said that the key to defining virtuality in terms of human experience rather than technological hardware is the concept of presence. Okay, so presence simply means that the feeling of being there or the sense of being there. Okay, as long as you feel that you are inside that medium, that virtual world, okay, we can see that it is virtuality. Okay, but of course, the definition is from the human experience perspective, just as Jonathan Stewart mentioned. Okay, he said the key to define virtuality is through human experience. Okay, but for us, you are taking the master's program in computing. Okay, so that's why we still need to talk about the technology. Okay, so normally when we talk about vividness and also interactivity, which are the two axes of that 2D plane for defining different medium. Okay. We are basically talking about breadth, depth, okay, for the vividness, and speed range mapping for interactivity. Okay, so breadth and depth, it is very easy to understand, right? So how large the space is, how detailed you can put into this space, what types of objects you wish to place inside this world, okay, with how much detail, for example, okay? So these are about vividness. For interactivity, we are talking about, for example, the tracking speed, tracking range, how your body can be mapped into the 3D space, okay? So in some cases, you can map your hands only, okay? There are technologies that can map your whole body in the virtual space, okay? So of course, you can do more interactive behaviors, okay? So for example, you can imagine that I just wear an ordinary VR headset, okay? I'm now standing on a football court, for example. I saw the football, I want to kick it, okay? I want to kick it, but there is no response from the system, okay? Simply because there is no technology to check the position of my feet, okay? So there is no such interactivity. So I can sense that I'm not part of this environment, right? So this is called the break of presence, okay? This is called the break of presence. Because if I'm really in the real environment, okay, I can kick this ball, I can kick the football, right? But in this virtual environment, I cannot. So I have the awareness that I'm in a virtual world, right? Again, we are talking about awareness, right? So in this case, it breaks my sense of presence. Okay, so in order to achieve that, we have to have the technology to track my feet in order to enable this interactivity, right? So that is mapping. We are talking about through mapping to interactivity and then to support human experience of sense of presence, right? So this is the example I just used, okay, to explain mapping, interactivity, and how vividness and interactivity can support sense of presence, okay? So any questions? Okay, so if no questions, let's move on to the next slide. I have already talked about that because the boundary is really blurry. You cannot call a particular thing virtual reality and call another thing not. So the very important thing is to make the adequate vividness and adequate interactivity for your application. Okay. Yeah, immersion. This is also another word. Okay, another term that you may encounter a lot when we talk about XR. Okay, have you ever heard about immersion before? Okay, have you ever heard about this word before? No? Okay, it seems that no one watched Apple's presentation of Vision Pro. Okay, so if you count, okay, immersive and immersion, okay, these two words during the whole presentation, you will find that they are mentioned many times. Okay, when they present Apple Vision Pro. Okay, but to me, as a VR researcher, okay, I would say that Apple used this word wrongly, incorrectly. Okay, why I say so? Because the early definition of immersion are very unclear. Okay, but now in the modern view, we do not use presence and immersion in an interchangeable way. We no longer use them in the interchangeable way. Okay, so when you talk with a VR researcher, you use the word immersion. Then we understand that we have the common sense that you are talking about the capability of the device. Okay, the capability of the device. When we talk about the experience, okay, when we talk about the experience, we will use the word presence. Okay, so this is the modern view. Remember, this is the modern view. Okay, so if you go back, for example, if you read some paper in the early 2000, you will find that these two words may be used interchangeably. Okay, but in the modern world, you are talking with someone who is doing VR research or who is a very experienced VR developer. Okay, you want to mention the capability of the device, you use immersion. Okay, you want to talk about the human experience, you use presence. Okay, so now you can see why I said Apple used the word wrongly. Why? Because Apple seldomly talks about the capability of the device. Okay, they always talk about the experience. Of course, Apple has changed, right, nowadays. Yeah, but yeah, they used to talk about the experience. Okay, so that's why that's why they should use a presence. But presence is a less exposed word, I would say. Okay, a lot of people are very familiar with the word immersion and immersive. Okay, yeah. So from the technological perspective, we always talk about immersion. So speaking of immersion, another very important thing that has been, been around for quite a while is about the 4 crucial technologies and the 4 auxiliary technologies to enable virtual reality. Okay. The 4 crucial technologies are the first one is the visual displays. It can also be oral and also can be haptic. Okay, that immerse the user in the virtual world that block out contradictory sensory impressions from the real world. Okay, so this is very straightforward, right? So when you wear the headset, you cannot see things around. Okay, unless it's a mixed reality headset. Okay, so we are talking about VR. Now, of course, these particular technology stands. Okay. The second one, the graphics rendering system that generates at 20 to 30 frames per second, the ever-changing images. Okay, so remember, this was published in 1999. Okay, so 20 to 30 is really high. Okay, so it's really high. I don't know for you, when I deliver a similar course at the undergraduate level, many people told me that, especially the students recently told me that they were born after 1999. Okay, so so yeah, so it's been quite a while. Okay, so that's why it is at 20 to 30, but we can treat this as a high refresh rate. Okay, so the second crucial technology should be the rendering at a high refresh rate. Okay. The third one is the tracking system that continually report the position and orientation of the user's head and limbs. Okay, including feet. Okay, but apparently many of the headsets, commercially available headsets, cannot track your feet. Okay. The last one is the database construction and maintenance system for building and maintaining detailed and realistic models of the virtual world. Okay, so do we have these technologies? Do we have these technologies? Yes, of course. Unity, right? Unreal. Some people even mentioned Origin. Okay, this is a really old engine. Okay, right? So all the game engines should be able to construct and maintain all the virtual assets, right, in your project. Yeah, so we do have all the 4 crucial technologies nowadays, right? Now, how about the auxiliary technologies? Okay, so the first one is synthesize the sound displayed to the ears, including directional sound and simulated sound fields. Okay, so this is something that's often be overlooked by XR developers. Okay, so the sound is quite important. Okay, in Unity, you can actually simulate this. Okay, very easily. Okay, using different plugins and also the built-in audio mixer. Okay, of Unity. Okay, to simulate directional sound. Okay, but to simulate sound in a very realistic way, it's super difficult. Okay. Later on, when we talk about the rendering, visual rendering, I will also mention about how to render the audio, okay, which shares a very similar property to light, basically. Okay. Yeah, so a lot of physical properties of sound, which is a mechanical wave, okay, share with the physical properties of light, which is electromagnetic wave. Okay, but yeah, the properties are the same. Yeah. So yeah, so for the first one, we can do the sound simulation at a relatively realistic level. Okay, but still you need to put a lot of engineering efforts in this. There is no, to be honest, there is no plug and play system. Okay, for rendering super realistic sound. Display of synthesized forces and other haptic sensations to the kinesthetic senses. Okay, this is not very common outside labs, okay, VR labs, okay. So for example, if I hold this bottle, I should feel the weight, right? So imagine this is a virtual one. I hold it, I cannot feel the weight, okay? For many of the commercial VR system, okay? So that's why we say so. The third one, devices such as tracker gloves with push buttons by which the user specifies interactions with virtual objects. Yes, we can do that, right? We have the controllers. The controllers may have joysticks. The controllers may also, be able to track your hands, your fingers very reliably. Okay, so for example, if you use the index, Valve index controller, okay, it can track your fingers. Okay, but of course, nowadays we also rely on computer vision based solutions to track your body, to track your fingers, track your arm. Okay, so yeah, so we do have this auxiliary technology. The last one, interaction techniques that substitute for the real interactions possible with the physical world. Okay, this is very tricky. Okay, so what does it mean by saying that can substitute for real interactions possible with the physical world? Okay, so this is a very generic definition. Okay, so just as I mentioned, I kick the ball, right? If I kick the football, then first of all, the football should fly. Okay, the second thing is that I should feel the sand. I should feel the football also kicks me, right? Right. So this is about force and force applied to my feet, right? So I should be able to feel that. So if we want to achieve that, I would say that first of all the vision, sound, haptic feedback should be rendered in a corrective way to make me feel that I'm in the virtual world. Sorry, in the physical world, right? So this is very hard to do. So that's why the last one is a very generic one. Okay, the very generic technology, and I don't think we are there yet. Okay, we are there yet. Yeah, so this is the specs of HTC Vive Pro. I will not go through it one by one, but as you can see here, these headsets, VR headsets, do have these 4 crucial technologies. Okay, but for the auxiliary technologies, maybe not. Okay. Yeah, next we move to the history of XR. Okay, so history of XR is very interesting. Okay, because even before analog age, people try to recreate or preserve the physical world. Okay, in certain ways. Okay, and for you to enjoy. Okay, without leaving your home. Okay, interesting, right? So for example, perspective, this is a very interesting thing, okay? So perspective is the very fundamental feature of Western painting in the, I would say, 15th century, okay, 15th century. Yeah, as you can see here, this is on the left-hand side, you are seeing a picture that is drawn between 1308 to 1311, okay? So this is 14th century, okay, 14th century. So there is no perspective, okay? Or the perspective is not correct. It's there, okay? People try to, draw in a perspective way, but it is incorrect, okay? On the right-hand side is 1426 to 1427, okay? We have a very correct perspective in this painting, okay? We have a very correct perspective in this painting. So you feel like on the right-hand side, you have a higher vividness, right? So we are talking about vividness again, okay? On the right, on the left-hand side, you still feel that, okay? But you always feel that there is something wrong. There is something simply because the perspective is not correct, okay? Yeah, this in the 16th century, in China, okay, we do not have perspective drawing, okay? So we live in a different way, I would say. We all often think things in different ways compared to the Western, okay, culture. And later on, when we have the film, photography, okay, people start to think about how to better preserve reality and then let you to enjoy in other occasions, okay? So we have this so-called stereograph, okay? So this is a typical stereograph. It contains the left image and the right image, okay? So it used 2 lenses Okay, and also 2 pieces of film, of course. Okay, digital was not a thing. This is in the analog age. Okay, so use film to preserve these 2 pictures. Okay, these 2 pictures are shooting by 2 different cameras. You can think about this in this way. Okay, and when you want to view it, you use this special device. Okay, so as you can see here, the left one and the right one, they are basically the same. Right? The left one, of course, is analog, right? It's analog. Okay. The right one, we just use the LED or OLED displays to actually replace the static images, right? The photos. That's it, right? So this is the digital age of XR. Okay. Of course, as I mentioned, it has already been, XR has already been around for quite a long time. Okay, and to your big surprise, actually, the first XR device developed and published in 1968 is actually an AR device, augmented reality device. Okay, it's not a virtual reality device. Okay, so we will see this one by one. Okay, so this is the this device is not called the sword of Damocles. Okay, this device is not called that. Okay, so but I don't know why people refer to this. It's always called the sword of Damocles. Okay, it is because of the demo, I think. Okay, so the demo basically is a storytelling of the sword of Damocles. Okay, so that's why people think that this entire device is called the sword of Damocles. Okay, it is not. Okay. So this is actually Sunderland's demo of an AR device. Okay, so this is a very interesting one. Why it is like so? Okay, you can hardly imagine that almost 70 years ago we have the capability of building this. Okay, so in order to build an AR device, remember this is an optical see-through AR device. Okay, so you have to develop the optics. Okay, the display system, right? And more importantly, you need to have the tracking system. Okay, the tracking system. So how this was done? Okay, so I've never experienced this. Okay, not like a Vision Pro. Okay, you can ask me a lot of details about Vision Pro because I just experienced that, in Apple's headquarters. But for this one, I've never, experienced that. I guess I'm not old enough. Okay. So, but I actually heard Sunderland actually talking about this device at IEEE VR, a conference. Okay, so he was the guest speaker there. So that's why I had a very short discussion with him about some of the details I was quite interested in. So I will try to explain this. Okay, so as you can see here, there are some very weird kind of devices on top of the user's head. Okay, so what are these for? Okay, what are these for? They are not for receiving signals from the aliens, okay? But instead, they are for receiving the signals from these sources, okay? So this one, this one, this one, and this one, okay? So these four devices are the emitters of radio waves, okay? Radio waves. So these devices are for receiving radio waves. Why it is like so? Okay, because the 4 emitters are tuned to different frequency. Okay, so the receiver can, based on the frequency, to determine the orientation and also precision of these of the headsets. Okay, and also you can see here, this is an optical see-through system. So that's why it has this very weird, like a Terminator kind of, device here. Okay, this is an optical see-through system. Okay, and when you wear the system, it is like so. I can play this video for you. Okay. Okay, so you can see here, it is the mechanical connection here. Okay, so there is a mechanical connection here. Okay, and also this is the demo. What you can see through the goggles. Okay. Okay, this is actually a video that you cannot find on YouTube. Okay, this is the video actually Sunderland sends me. Okay, so yeah, let me play it again and let you have a look. So as I mentioned, these receivers can actually track the orientation of the headset, but they cannot track the position. Okay, so that's why there should be another mechanical connection to determine the position of the headset. Okay, so it can track the headset in a 6 degree of freedom fashion. Okay, 6 degree of freedom. We will talk about this later on. Okay, but for short, it can track the position as well as the orientation. Okay, so this is the tracking device. And also, I just want to share with you a very interesting thing I heard from Sunderland. Okay, so as you can see here in this picture, there is a black thing on top. Okay, a black thing on top. No one paid attention to this, but this is actually why the demo will not work during winter time. Can you imagine why? This is something that Sunderland actually shared during the conference. Okay. Can you imagine why? Why this very black dark thing on top will make the demo not working during winter time? Okay, so this is actually the heater, okay, for this lab. The heater will blow the wind and then affect the radio frequency. Okay. So that's why the demo will not work during winter. Okay. Okay, so yeah, this is just something I want to share with you. Okay. Okay, so the next thing I want to share is called the Aspen movie map. This is also a very old demo. Okay, this is also a very old demo. It was originally published in 1980. Okay, so it's more than 40 years ago. Okay, so this is the first attempt to create something that is very similar to Google Map. Okay, the immersive version, more like Google Earth. Okay, so it just models different buildings or the streets in a city called Aspen. Okay, so that's why this is called Aspen Movie Map. Okay, so as you can see here, this is how we achieved the first system that can manage the large amount of 3D data. Okay, 3D data, and also associated problems such as rendering problems, interaction problems, how the audio, video, and other information can be stored. Okay, so this is the first attempt to build Google Earth. Okay. Okay, so this one, as you can see, this is more close to the headset we see nowadays. Okay, so this is called the NASA View system. Okay, so this system is as I mentioned, very close to the headsets we see nowadays. It has no mechanical attachments. Okay, it uses the microphones and also the smaller LCD displays. Okay, to display images, and it has the data gloves. Okay, data gloves to actually let you to interact with different objects. Okay, it was originally designed to train astronauts. Okay, so this device was in partner with VPL. Okay, why I mentioned this particular company here? Okay, so this company no longer exists. Okay, no longer exists because the owner or the creator of VPL actually first coined the word virtual reality. Okay, so virtual reality was not a thing. Okay, no one called this virtual reality. Okay, but Jaron actually is the first people call this device virtual reality device. Okay, he is a very interesting person. Okay, so yeah, so he actually used the term virtual reality to describe this 3D rendering graphical thing. Okay, so during that period of time, Jaron actually spent a lot of time selling these, very similar replicated systems to universities in the US. Okay, so he sold a lot of these devices, but he never had a very fancy word. Okay, to sell this to NASA. Okay, so you can imagine that when he started his business, he started to sell this the 3D rendering computer graphics device to computer science professors, right? So they can quickly grasp the idea by looking at this very long term, right? But when he wanted to sell this to NASA, NASA people do not have the in-depth knowledge towards computer rendering. You can imagine this is in 1990. Okay, so they do not have such deep knowledge. So Jaron spent some time to think about how I can call this device, how I should call this device. Then he come up with the word virtual reality. Okay, and when he invented this word, coined this word, everyone is calling virtual reality. Okay, so this is such a good term for his device. Okay, so I also prepared a video for you to have a look at this NASA view
唔識
system.
睇緊 live 嘅你又
Yeah, so this video was originally in NASA's archive. Okay, so someone, I don't know how they can actually get hands on this video, but they upload it to YouTube. Yeah, as you can see here, they use the data gloves to actually do these, interactions. Okay, so this is a rendering of the lab. Okay, so as you can see, it's super simple. It's yeah, and also you can see your hand. This is for enhancing the embodiment, and also to let people know where their hands really are. Okay, in the virtual world. Yeah, so you can imagine that the number of polygons for this hand may be the same as the total environment. Okay, so to make a super realistic hand, at least you have a great number of polygons in order to do it, right? But for the environment, it's super low resolution in terms of the number of polygons. Yeah, so you get the idea. Okay, so this is the technology from 1990s. Okay. Yeah, you can also interact with text menus. Okay. Okay, so this is the NASA view system. So till then, I think most of the VR headsets are used by professionals. Okay, either for training astronauts, fighter jets, pilots, people like that. Okay, but the first commercial product of VR headset actually come from Nintendo. Okay, quite surprised, right? Nintendo actually made these Virtual Boy VR devices. Okay, it was originally published in 1998. Okay, and they have this so-called red monochrome display technology. Okay, so this is another very interesting technology. Yeah, but I'm afraid that I do not have the time today to introduce you, but we will save it for the next lecture. Okay, so this is a very good device. It used a very clever thinking behind to actually use a single sling of LED, okay, to display images. Okay, so it is very, you can imagine that you only have one stream of the pixels on your monitor, but it can display the entire image. Okay, how can you do that? Okay, how can you do that? So that's why there are lots of clever thinking behind this. But unfortunately, I think this one is not very popular. Okay, it's not very popular. I actually tried to buy one from eBay. Okay, and I cannot find a working one. Okay, unfortunately. Okay, I tried to to buy one to let you to experience it. Okay, but I cannot find a working one, on eBay. I will try to, look for it. Okay, I will try to look for it. But if you go online and you go to YouTube and search Nintendo Virtual Boy, I think someone bought this device in full working condition. And also he also bought some games for this, so you can have a look and experience it, virtually. Again, virtually. Okay, through YouTube. Yeah. So this is about the LED technology. I just want to mention, but I will save it for the next lecture. Okay, so that's it for today. So I will see you next week. Okay, so remember, next week we are going to start the tutorial at 6:30. Okay, 6:30.